Ernst Mach, born 1838, died 1916. Here's a picture of the gentleman. You see that? The Czech-born physicist and psychologist Ernst Mach was one of the pioneers in the study of aerodynamics. His work had important consequences in the development of aeronautics and supersonic aircraft. His biggest contribution to the field of science was in reviving and expanding the philosophical school of scientific positivism. This consisted essentially of rigorously verifying basic principles and assumptions rather than working from hypotheses and suppositions. Mach was born in Turas, now in Czechoslovakia, and became a professor of mathematics at the University of Graz, Austria, in 1864. In 1867, he went to Prague as a professor of physics and remained there for 28 years. His most influential book, The Science of Mechanics, a critical and historical account of its development, was published in 1883. And in it, he argued that the concept of mechanics were only valid insofar as they could be verified by empirical observation. To fall back on imaginative or intuitive reasoning was for Mach to become involved in metaphysics. He took his arguments a stage further in Contributions to the Analysis of Sensations, 1886, asserting that the experimental data from which we develop ideas and construct theories are in themselves neutral. Hence, in the psychology of observation, the phenomenon being investigated can be investigated and understood only in terms of the experience which the investigator is undergoing. So basically, he looked at experimentation and that kind of stuff as the prime for everything, and you couldn't figure anything out using your intuition because that was metaphysics. But we know better. Intuition has a very large role in understanding nature. You have 4.5 billion years of evolution sitting on top of your shoulders. That's what intuition is, my friend. It's something that human beings have that animals don't. In the positivist tradition, hypotheses and theories thus became convenient fictions, which might or might not be useful tools in the assembling of objective knowledge. At this stage of scientific history, no one had as yet observed an individual atom. To the positivist, therefore, atomic theory was only a convenient fiction. Mach himself became one of the most determined opponents of the atomic theory of matter. Until there was empirical evidence for the existence of atoms, his view was that their objective reality should be denied. For similar reasons, he rejected the concept of absolute time and space in Newtonian physics. He considered such speculations not to be the true concern of science. This guy was very interesting, and I'm surprised people haven't been talking a lot about this gentleman, because the guy who understands shock waves and sound, check it out. Check out all those diagrams. I'm sure there's a lot more diagrams online if you go look them up. But this guy didn't believe in atomic theory, and for good reason, which I'll explain in a little bit. Alright. His denial of Newtonian space and time did, however, have a positive influence on the thinking of a young scientist, Albert Einstein, who at that time was in the process of formulating his theory of relativity. No, it's not the theory of relativity, it's special relativity. And then general relativity came after the fact, and that's when he just completely lost it, and he tried to explain gravity in terms of warping space, which is nonsense. Mach's intellectual stature and his critically uncompromising stance before all projected theory made him a significant figure in the evolution of modern scientific thought. Further developments in physics and psychology, as well as the modern empiricist schools of philosophy, owed much to his theories. Critics of Mach's viewpoint, on the other hand, have pointed out that positivism in its ultimate form represents a flight from reality rather than a coming to terms with it. In the end, all observed truths have a significance and validity only as a phenomenon of the mind. The term Mach number was coined in recognition of Mach's pioneering work and studies, which he made the behavior of objects in wind tunnels, working out the ratio between the speed of sound and the speed of the body in undisturbed air. These were a primary influence on the development of the theory of aeronautics. The Mach number is now used in modern aeronautics to express the velocity of an aircraft or projectile in relation to the speed of sound within the environment in which it is traveling. Thus, Mach 1 is a velocity equal to the speed of sound, and any speed above that becomes supersonic, Mach 2 representing twice the speed of sound, and so forth. The characteristic sonic boom from a supersonic aircraft is created by sound waves hitting the ground when the aircraft slows down or turns. So this guy is very, very, very interesting. I'm also going to read more up on him in the future. As well, I want to bring a greater understanding to my listeners. When they try to look for discoveries, don't try to look at things in the horizontal, or in the vertical aspect, where everything flows in down to up or up to down fashion. Try to look at things more horizontal as well. So for instance, if you have a stationary source and a subsonic source, see those two pictures right there? There's a stationary and a subsonic, and then you have your supersonic. What does that remind you of? That reminds you of atomic orbitals, doesn't it? Maybe there's something there. Maybe there's a property of matter itself which causes there to be a sound barrier, meaning it has nothing to do with the actual speed at which the object travels, but it has to do with the fundamental property of matter itself. So if we can understand how matter interacts with other matter when it travels really fast, we can probably reach a different conclusion based off of these kinds of principles as to the fundamental properties of nature. Meaning, maybe he was right all along, and atomic theory is not really true at all. It's just the way matter behaves, which gives the appearance of there being an atomic theory. But anyways, that's a bit outside of the status quo. But to really think about it, really try to look at things like this and connect seemingly unconnected areas of science. That's how I made the discovery when I was looking at the stellar evolution page, and I noticed that they had a evolving star, such as an evolved star with iron core, magnesium, silicon, and hydrogen, oxygen, helium, all that on the outside. I was like, wait a second, that's the Earth. And then I discovered that the Earth is an ancient star. I was like, wow, stellar evolution is planet formation. That's incredible. So to think, if Mach's principle can lead us to an alternative understanding of what atoms really do and what they are, maybe we can design craft that can travel faster than the speed of sound without actually breaking the sound barrier, because we can manipulate the actual fundamental properties of the matter itself. Which means Elon Musk could be effectively put out of business with his rockets. Well, that being said, we wouldn't need to really go that fast. We could possibly understand what causes inertia and mass itself if we were to understand how matter behaves when it travels at very high velocities, much less, breaking the sound barrier. But there he is, Ernst Mach. Very interesting character. I suggest studying aerodynamics. Very, very important. How matter behaves through fluids. But also keep in mind that the majority of the information concerning aerodynamics are for subsonic airfoils and things like that. Try to think in terms of supersonic and what's actually happening at that boundary between the craft and the fluid which it travels through. That will bring more understanding. But there you go. Today is August 28th, 2015. Everybody have a good day.